Welcome to the binomial theorem, arguably the toughest topic you will learn on your AP pre-calculus test. Now, binomial theorem is such a topic that if you want to score well, and by well I mean a score of 4 or 5, you need to know this topic because I guarantee you that they will ask at least one question on binomial theorem, maybe two, and possibly three. And since pre-calculus students are quite new to the world of math, they're not comfortable or familiar with the notations of, summation and choose k and stuff like that, and all the factorials. And when you look at this statement, it looks quite daunting and tough. But today I'll break down the binomial theorem in such an easy way that you'll feel that it is the easiest and dumbest thing you'll ever learn. So let's dive right in. Well, my friends, here it is, the binomial theorem. It says that if we want to expand x plus y whole to the power n, then the answer would be summation k equal to 0 till n of n choose k times x to the power k times y to the power n minus k, where n choose k is equal to n factorial upon k factorial into n minus k factorial. Hard, isn't it? But now I'll be breaking it down into three parts. I'll be breaking this equation down into three parts, and it will be super easy. The first part will be the summation one. The second part will be the combinatorial one, n choose k, we call that n choose k. And the third part will be the exponent right at the back. And at the end of the video, it will be super clear to you when you add the three of them together. So let me start with the summation one. Now, if you want to pursue math going ahead, or even if you don't want to, the summation notation is something that you should be familiar with. It is denoted by a Greek letter sigma, which is written as this, a kind of an E, but not exactly one, and it has three main parts, one on the top of it, one at the bottom, and another one written in this part after the summation notation. Now I'll be explaining each one. So the bottom part right here says from where do you start your summation? At what point do you want to start summing your numbers from? The top part tells the opposite. It tells you where do you want to stop your summation? Till which number do you want to sum up? And the box right here tells you what do you want to sum up. For instance, if I have summation A equals to 2 till 7 of A. This means that I will start from A equal to 2. The answer of this would be A equal to 2 plus 3 plus 4 plus 5 plus 6 plus 7. Alright, that is what it says. It asks us to start from A equal to 2, which we started with 2, and it says you have to stop at 7, and we ended at 7. And what do we need to add? We need to add the value of A. So the answer of this, whatever we get, that would be 13,822, and that would be 27. So the answer of that would be 27. Now, instead of an A, if I had 2 times A, then my answer in this case would be, when I put A equal to 2, then I have 2 times 2, which is 4. When I put 3, I get 6. When I put A equal to 4, I get 8. And so on, you go on adding till 14 to get whatever your answer is. So that is what is meant by summation notation. The variable on the bottom tells you where you start from, the variable on the top tells you where you end, and the thing after the summation notation is what you actually add up. So when you look at the binomial theorem, you have summation k equal to 0 till n. It means that you start from k equal to 0 of n choose k, which means you first put the value of n choose 1, and then you put n choose 2, and so on. You keep on putting in values till you reach n choose n, because it asks us to stop at n. Alright, that is what is meant by a summation notation. Now, the second part that we have here comes from a branch of mathematics which we call combinatorics, and it may be new to like most of the pre-calculus students since they're generally new to the world of math. Combinatorics generally deals with counting stuff, or counting ways, counting possibilities, counting the different ways for an event to happen, and so on. I hope you get the idea that combinatorics is generally related with counting possibilities. Now, the term that you have right here, the first one, with an n and k written inside a closed bracket, that is what you call a combination. It is written as nck with a capital C, and it is read as n choose k. And the essence of n choose k is that it gives you the number of ways, or the total number of ways you can choose k objects out of n objects. I repeat, it gives you the total number of ways you can choose k objects out of n objects. For instance, if I have 5 toys, one is white in color, other is orange, other is red, a blue one, and a pink one. Then in how many different ways can I choose my toys? I could either select these three, white, orange, and red. I could either select these three, red, blue, and pink. I could even go with white, orange, and blue, or maybe even orange, red, and pink. Who knows how many ways are there? So, what a combination does is that it gives you the total number of ways you can select a different set of objects. Now, the formula that you have right here, n factorial upon k factorial into n minus k factorial, this has a combinatorial proof for which you'll have to learn permutations and stuff like that, and it is not necessary from your course point of perspective. So I'll be directly explaining you the formula, how it works, and I'll give you a video of the proof if you want later on after the course is over. Now, if you're not familiar with the factorial notation, a factorial means you multiply the number itself and all the integers less than it up till 1. For instance, if I tell you 5 factorial, 5 factorial essentially is 5 times 4 times 3 times 2 times 1. The 1 is insignificant, but we write it. If I ask you 10 factorial, then we write 10 times 9 times 8 times 7 all the way down till times 1. In general, if I tell you n factorial, it means n times n minus 1 dot 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 all the way till 1. That is what is meant by factorial. You multiply the number itself and all integers less than it up till 1. Now, I'll give an example of how this works. In this case that we had right here, what I explained you, we had 5 objects and we had to pick 3 of them. So in this case, our n would be 5 and k would be 3, since we are interested in finding the number of ways we can pick 3 objects. According to the formula, if I have 5 choose 3, which is n factorial, which is 5 factorial upon 3 factorial times 5 minus 3, which is 2 factorial. If I expand this, I have 5 times 4 times 3 times 2. The 1 is insignificant. 3 factorial, 3 times 2, 2 factorial times 2. If I start cutting down, I can cut down a 2, I can cut down a 3, I can cut down this 2, and I'll get 10. So there are 10 possible ways in which you can pick 3 objects out of 5. That is what is meant by n choose k, nck, and it is very useful in a binomial formula, especially from your test perspective. And I hope that was clear. The third part that we have right here is the exponent one, where we have n x to the power k times y to the power n minus k. Now, people may understand this quite well, but I'll explain you why is it like this and the reasoning behind these specific exponents. Now, if I ask you x plus y whole to the power 5, what do you mean by this? It means that I multiply x plus y with itself 5 times. Let us write it down. X plus y times x plus y times x plus y times x plus y, that is 1, 2, 3, 4, and the last time x plus y. This is what you have. Now, when we're dealing with this, we don't know which term goes with which one, so we work with each of them individually. Now, I'm going to change your perspective right now. Instead of taking an x plus y, consider you have 5 buckets, and in each of those buckets, you have two toys. One is toy x and one is toy y. Now, from each bucket, you are supposed to pick one toy. For instance, in the first try, I pick an x. Okay, from this bucket, I pick an x. From the second one, I pick another x. From the third one, I pick another x. From the fourth one, I pick a y. And from the fifth one, I pick an x. Now, what this essentially gives me is that it gives me the exponent. This entire thing will turn out to be an x to the power 4 plus y. If I were to choose two y's instead of an x, maybe if I took a y here, then I would have x to the power 3 times y to the power 2, because I have two y's and I have three x's. Now remember that each and every term, each and every x and each and every y will get multiplied with every term in this entire product. And that often makes it very messy. So we pick one by one, we pick each variable one by one, and I'll explain you how clear it is when you actually go into that. Pardon, what's happening? Yeah. Now, if you were to expand this, first you will take all the x's, alright? From all the buckets, you will take 5 x's. So I have an x to the power 5 as my first term. Remember, we are not dealing with the coefficients right now, we are just dealing with the variables. In my next chance, I pick one y. Let's say I pick a y from here and I pick 4 x's over there. We have x to the power 4 plus y. And then in the same way, I'll pick two y's this time and have 3 x's. I have x to the power 3 plus y to the power 2. And I hope you can see the pattern right now. Now I pick 2 x's and 3 y's. Then I pick an x and 4 y's. And then I finally pick 5 y's. And that is why you have a k up here and an n minus k here. Because if you sum the exponents, you have k plus n minus k, where k essentially cuts off to just leave you with an n. And when I say buckets, and if I give you 5 chances, it means that irrespective of whether you take an x or a y, you will pick 5 toys from 5 buckets. So at the end, the total thing that you have in your exponent will remain 5. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 5. 4 plus 1, 5. And 5 is 5. So that is why the exponent is written in the form of x to the power k into y to the power n minus k. Now you may ask, for instance, in this term, x to the power 3 times y to the power 2. What instead of picking y from these two buckets, I decide to pick y from these two buckets? What about that case? We did not consider that. That is what a coefficient does. It counts how many times will x to the power 3 times y to the power 2 will appear. How many ways can you make x to the power 3 into y to the power 2, which is exactly given by the second step, which is the NCK. Now I hope things are clicking to you. Again, take 5 buckets. You can either choose x or y from each of them. And now to make x to the power 3 into y to the power 2, I need to figure out the number of ways I can pick 3 x's, which is given by 5 choose 3, which we already counted was 10. So the exponent, so the coefficient of x to the power 3 times y to the power 2 will be 10x cubed y square. Alright, because that gives me the number of times x to the power 3 times y to the power 2 will appear when you do a full multiplication. And this is quite an amazing shortcut. So I hope that was very clear to you. Now what you have right now is exactly how a question will appear on your test. You'll have different numbers instead of x into y to the power 3, but this is how they'll ask you. Find the coefficient of x into y to the power 3 in x minus 3y whole to the power 4. Now, whenever you're working with the binomial theorem, do not look at the formula. Just think of the bucket example and choosing your two toys. Again, I have four buckets. One is toy x and another is toy minus 3y. Firstly, I'll pick 4x's. Then I pick 3x's and I'll stick with one negative 3y. Make sure to take the negative sign with it as well and keep it in brackets. Then I pick 2x's and a negative 3y whole square. Then I'll probably pick x to the power 1 into minus 3y whole to the power 3. And finally, I'll be picking a minus 3y whole to the power 4. Now, if I work with this thing, in the next step, I will have an x to the power 4 as it is. And now, I want you to be aware of the sign. Don't make any mistake like I just did. A negative 3y to the power 1 will become a negative 3x cubed y. A negative 3y whole square will become a 9x squared y squared. A negative 3y to the power 3 will become a negative 27 y3x. A negative 3y to the power 4 will be a positive 81 y4. Now, what is the coefficient we're looking for? We're looking for the coefficient of x times y to the power 3. Do we have it here? No. Do we have it here? No. Do we have it here? No. Do we have it here? Yes, we do. We have an x into y to the power 3. I have just switched the order. Now, some people, and many people, will in a hurry choose 27 as a coefficient. But remember, this is just one appearance of x and y to the power 3, and that one appearance itself has a 27 as a coefficient. So we'll first calculate the corresponding combination, which is I have four buckets, and I'm expected to pick three toys. 4 choose 3, which will be 4 factorial upon 3 factorial, 4 minus 3, 1 factorial, which will be 4 into 3 into 2 upon 3 into 2. We cut this to get 4. So finally, your coefficient would be 27 times 4, which would be 108. So the coefficient of x and y to the power 3 and x minus 3y to the power 4 will be 108 and not 27 or 4. I hope that was very clear. You have to take care of this coefficient and even take care of this one that we already have in front of it. And no, I made a mistake. It will be negative 108 because you have the negative sign. So I think that should be the end of it. This is a tough topic, so don't worry if you don't get it in the first try. Watch the video again and you'll get it soon. Thank you. We'll meet again.